Problem 4, find the derivative of what? Firstly, y equals x squared plus 5x plus 6 all over x plus 2. So if we look at the workings for a, then there's my basic function. And what I want to do is simplify the expression. So given that that's a quadratic and I've got a linear factor down the bottom, what I hope to do is factorize the top line and hope that that cancels out with one of the factors of the top line cancel out with what's on the bottom. So I factorize x squared plus 5x plus 6, and I get these two linear factors. Down the bottom we've got x plus 2. Then fortunately these two cancel each other out, and I'm left with x plus 3. So this statement here is equivalent to saying that y is equal to x plus 3, and now I just need to take the derivative of that. So the derivative of x is just 1, and the derivative of 3 is 0, so dy dx is equal to 1. So it works out nicely for me. In B, I've got y equaling 2x squared minus 6x plus 1 all over x. So here I have it written down, and all I want to do here is divide each term by x. So you can see I've got 2x squared on x minus 6x on x plus 1 on x. Simplifying these, I end up with 2x take away 6 plus x to the power of negative 1. This is a format that I can easily work out the derivative of. So dy dx is equal to the derivative of the 2x part is just 2. The derivative of negative 6, which is a constant, is just 0. And then I'm adding to it the derivative of the last term. And the derivative of the last term, the power comes down, so the negative 1. I multiply by x to the power of the original power, take away 1. So it's going to be negative 1 take away 1, which is negative 2. Tidying things up, I end up with 2 take away x to the power of negative 2. And then finally, I would prefer to write everything as a positive power. So rather than have x to the power of negative 2, I bring the x down to the bottom and write it as a positive 2. So if y equals 2x squared take away 6x plus 1 all over x, its derivative is equal to 2 minus 1 on x squared. And of course I could verify that with a CAS calculator if I chose. 5. Calculate f prime of 3 given that f of x equals 3x squared multiplied by x plus 2. Looking first of all by doing this by hand, here's the original function. And my first job is to expand the original function. So I'm multiplying the 3x squared through x plus 2. So I come up with this when it's expanded. And now I work out its derivative using the normal procedure. So the 3 comes down. I multiply by the 3 that's in front of the x. I multiply by x to the power of the original power, take away 1, so to the power of 2 in this case. Plus, looking at the second term, the original power comes down, which is a 2, multiplied by the 6, multiplied by x to the power of the original power, take away 1, so 2 take away 1, which is just 1. Tidying that up, I am left with f prime of x equaling 9x squared plus 12x. I need to evaluate f prime of 3. So all I need to do now is substitute 3 into this derivative function. So substituting 3 into this derivative function ends up producing 177, and you can see the workings there. There's nothing too alarming about what we need to do. We can easily do this on our CAS calculator as well. My first job here is to define the function. So I'm going to go to Menu, Actions, and then Define. I'm going to define f of x. So it's f of x equaling 3x squared multiplied by the bracket x plus 2. And there is f of x defined. What I want to do now is find the derivative of f of x given that x is equal to 3. So I'm going to go to Menu, Calculus, and then I want Derivative. I want to find the derivative with respect to x, so I'm going to put an x in here. The function I'm finding the derivative of is defined already, and that's f of x, so I'm going to put in f of x, and of course the little f is bold now because it is defined. And I'm just going to move the cursor across. And this is where I take into account the fact that I want x to equal 3. So what I'm going to do here is go Control and equals and make use of the given that symbol. X is equal to 3. And hit enter, and there's my result, 117. Please note that I don't put x equaling 3 in at this stage. Let's do that now and see what the result is. So menu, calculus, derivative, and I'm doing it with respect to x, and then it's going to be f of 3, and hit enter. And the result is 0. And the reason for this is because what the calculator does is that first of all, it evaluates what f of 3 is. So it takes 3, throws it into the original function. And of course, when you do that, you're going to come up with some kind of constant. That constant is then going to be thrown in to this derivative expression. And if you take the derivative of a constant, you're always going to end up with 0. So what we need to do in questions like the one that we're given is say, okay, we're finding the derivative of f of x, and then we stipulate that x must be equal to 3. If you go about it in this way, you'll always come up with a result of 0, which will be incorrect. And this is always tested, particularly at Year 12 and 11 on examinations. 6. Finding the coordinates of the points on the curve where y equals x cubed takes 6x, at which the gradient equals 30. So in other words, what we've got here is some type of cubic curve, and we're interested in the x and y values where the gradient is equal to 30. So here's my original function, y equals x cubed takes 6x. I work out the derivative in the usual way. In my next line, I let the gradient, the y dx, equal 30, so I have 30 equals 3x squared takes 6. I obviously add 6 to both sides. I then divide both sides by 3, and I end up with the equation 12 equals x squared. In my next line, I take the square root of both sides, and I end up with x equaling plus or minus the square root of 12. The square root of 12 can be simplified to being 2 multiplied by root 3. So x can be positive 2 multiplied by the square root of 3, or x could be negative 2 times the square root of 3. In the next column, all I'm going to do is substitute the found x value into the original function. The first found x value I'm going to deal with is positive 2 times the square root of 3. So here's the original y function. I substitute x equaling positive 2 multiplied by the square root of 3, and then it's just a matter of tidying things up in each line. You can see here that I cube everything. I cube the 2 and I cube the square root of 3. I end up with this, and then tidying everything up, I end up with 12 lots of the square root of 3. So my first point, x equals 2 times the square root of 3, and y equals 12 times the square root of 3. That's one point. But we've also got to consider when x is equal to negative 2 times the square root of 3. So I substitute x equaling negative 2 times the square root of 3 into the original function. Again, I need to cube both the negative 2 and the square root of 3. And of course, I substitute negative 2 times the square root of 3 in for x here. You can see the basic algebra coming through, and I end up with y equaling negative 12 lots of the square root of 3. So my second point is x equaling negative 2 times the square root of 3, and y equaling negative 12 times the square root of 3. I made a bit of a point here saying that this is a particularly tough question involving two lots of the square root of 3, but the basic process is something that you really need to understand and something that you should be able to deal with in exam 1. Problem 7. Given that f of x equals x squared plus 16x plus 3, find a. f prime of x, the gradient function, b. the gradient when x is equal to 5, c. the coordinates of the point at which the gradient is equal to 8. So looking at a, here's the original function, x squared plus 16x plus 3. So I need to work out the gradient in the usual way. The 2 comes down, I take a 1 away from the power, and then I look at the second term, 16x becomes just 16, and then the gradient of positive 3 is just 0. So there is my gradient function, f prime of x. In b, I'm asked what is the gradient actually equal to when x is equal to 5. So I take my gradient function and I substitute x equaling 5 into it. So I substitute 5 and I end up with number 26 as my answer. So the gradient is equal to 26 when x is equal to 5. In C, I need to find the coordinates of the point at which the gradient is equal to 8. So in this case for C, I've got f prime of x, the gradient function, is equal to 2x plus 16, previously worked out. I make the gradient equal to 8, and then I end up solving for x. So I end up that x is equal to negative 4. So that tells me that when x is equal to negative 4, the gradient, how steep the curve is equal to 8. I then substitute this found x value into the original function. So here's the original function here, f of x. I substitute negative 4 into it, and I get negative 45 as a result. So the point on f of x where the gradient is equal to 8 is when x is equal to negative 4 and y is equal to negative 45. Notice that to answer this part C, I need a point. I need an x value and a y value. The x value is found by simply taking the gradient function, making it equal to 8 and solving for x. The y value has been found by taking that found x value and placing it into the original function f of x. Problem 8. Find the coordinates of the points at which the tangent to the curve f of x equals x squared minus 4x plus 4 is A, parallel to the line g of x equaling 2x plus 1, and B, perpendicular to the line h of x equals 3 minus 2x. So both of these g of x and h of x equations, the information that really is relevant here is the gradient of them. So in g of x the gradient is 2, and in h of x the gradient is negative 2. And we'll be using that bit of information to help us answer really what we're after here, which is locating the point on this curve involving these gradients. So in A, we want to find where it's parallel to this equation. So we need to find the point on f of x where the curve is parallel with this. So in other words, we want to find the point on f of x where the gradient is equal to 2. So let's look at it. So g of x equals this, the gradient is equal to 2, so parallel means that they have the same gradient, of course. So here's my f of x equation. I work out its derivative in the usual way. I make f prime of x, the gradient, equal to 2, and I solve for x. So x equaling 3, I have found the value of x for the point on the curve where we have a gradient of 2. So that's the x value. Of course, any point is defined as being an x value and a y value. So what I need to do is substitute the found x value into the original f of x equation. So here's f of x, I substitute x equaling 3, and I produce 1. And from that, I'm able to say this. At the position 3, 1, the curve has a gradient of 2, which is parallel to this g of x line. Let's now consider part B. We need to find the point on the curve where the curve is perpendicular to this h of x line. The first thing to realise is that whilst h of x has a gradient of -2, we're trying to find where the curve has a gradient of a gradient which is perpendicular to -2. So using my m of t multiplied by m of n, or m1 times m2 with a result of -1, I'm able to work out that my perpendicular gradient would be equal to 1/2. Where on the curve is the gradient equal to 1/2? Again, I make use of the derivative function. I let the derivative equal 1/2, and I solve for x, and I end up producing 9/4. That's only a part of the answer, of course, because I need to work out a y value as well. So I substitute that found x value into f of x, and I get a result of 1/16. So I can say at the position 9/4, 1/16, the curve has a gradient of 1/2, which is perpendicular to the line h of x. So this is how we'd answer it using pen and paper, a typical response for exam 1 type questions. If you had exam 2, then you're able to make use of your CAS calculator. Alright, so we've seen how we can solve that problem 8 using pen and paper. That works well for exam 1, but in exam 2 we might want to be a little bit more efficient, so we'd be interested in making use of our CAS calculator. The very first thing I would do to solve problem 8 using your CAS is define f of x. So I'm going to go to Menu, Actions and Define, and put in there that f of x is going to be equal to x squared, take 4x, plus 4. Hit enter and I've defined it. Now what I need to do is make use of the solve function and also the derivative function. What I'm going to do is take the derivative of f of x and make it equal to 2, because I'm interested in finding where the point where the gradient is equal to 2, that is, that it's parallel with that g of x function that has a gradient of 2 also. So I'm going to go to Menu, Algebra and Solve, and now I'm going to make use of the derivative function, so Menu, Calculus and Derivative. I'm doing it with respect to x, and I'm going to just put in here f of x, which has already been defined. Okay, so firstly what we can see there is that I'm working out the derivative of f of x, and I want the derivative to equal 2. And now I need to tell the CAS calculator that I'm solving for x. And if we move out there, you can see the syntax. Hit enter, and you can see I produce x equaling 3. So that is the x value for the point where the gradient of f of x is equal to 2. To work out the y value, I just simply substitute 3 into f of x. F of x is defined, so I'm just going to have f of 3. Hit enter, and you can see I get a result of 1. So the position where f of x is equal or is parallel with g of x is at the position 3, 1. In part B, we need to find the point on the curve f of x where it is perpendicular to h of x that has a gradient of -2. So in other words, I need to work out where the derivative of f of x is equal to 1/2. Why 1/2? Perpendicular gradients multiply together to produce -1, and basically all you need to do here is, as a little trick in your head, is remember that you need to flip the first given gradient and change the sign of it. So the perpendicular gradient to -2 would be positive 1/2, positive 1/2. So similar type of technique, I'm going to make use of the solve function, so Menu, algebra, and solve. Again, I'm looking at the derivative function, so menu, calculus, and derivative. And I'm doing it with respect to x. And I'll just move across. I've defined f of x, so I'm going to put in f of x here. And it's equal to, and this time I want it to be equal to 1/2. Notice I don't put in 0.5. And I want to solve that for x. Hit enter. And I get 9/4. And again, I just want to work out the corresponding y value. So it's just f of, and I'll put in the exact fractional format, 9/4. And hit enter. And you get 1/16. So the point that we've just found is 9/4, 1/16. So that tells us the point of f of x where f of x is perpendicular to the h of x function.